And welcome back to Tech Talk with Ray and Mike. How's it going, Ray?
All right.
I'm excited about today's podcast.
Oh,
here.
yeah, this is going to be fun.
We're talking
cool stuff.
Spacey stuff.
Yeah.
That's going to be a good one. Well, welcome back to Tech Talk. We are powered by Standard Time, which is a great time tracking app for everyone who wants to track their time and invoice employee or clients and
right.
all that stuff. If you want more information, you could go to our website at stdtime.com. Encourage you to subscribe to all these podcasts. That just means that whenever we post something new, you will be the first to know.
Yeah.
And that's a good thing.
And leave a comment.
Leave a comment.
If you hate it.
Yeah.
If you love it.
If you hate it, then we'll ban you from the podcast. It's fine.
And it's
That's
all
okay.
tech talk, so if there's some obscure technical thing that we got wrong,
let us know. Or if there's something you want us to talk about.
Yeah, that'd be
sure. Subject matter is good. So, subscribe. Make sure to do that. So, today we are talking Juno, and not the email program from the late 90s. Remember Juno?
Remember that? I do.
I still have a Juno account. That's my
Really?
junk email account.
Is it still alive?
It is still alive, and I'm surprised. Well, I don't know if it's still alive, but every time someone says, "Hey, we need your email address," I just give them my Juno account, and they accept it. So I'm assuming it's still alive. But yes, not Juno.com, but more Jupiter Juno.
Yeah, the
But not the
spacecraft.
Juno goddess, but the Juno,
Greek god, right?
Yeah,
Goddess, right?
But the actual Juno spacecraft that went up to Jupiter, right?
Sure. We all heard about it.
Yeah, we all heard about it, and we thought, hey, let's talk about it. And for people who don't know, we can explain what's going on here.
Yeah.
So, let me hit him. We're not on baseball anymore.
Oh, yeah. So for you listeners, what Mike's referring to is a little episode we did on baseball. Now,
Yes.
you would not think that baseball is a tech topic.
It was. So much so that we spent a lot of time on, it's very
It was
scientific.
a long segment.
Yeah, it was. So I was looking at my questions for baseball. So I was going to say, so how long does a fastball? And I'm like, wait, we're talking Jupiter here. So you obviously can't get to Jupiter
With an airplane?
with an airplane, and they didn't shoot, Juno up with an airplane. How long did it take Juno to actually get to Jupiter?
Well, it turns out they launched Jupiter August 5th, 2011. So
That was a long
as of this podcast, we're talking 5 years. It took almost 5 years. I think it went into Jupiter's orbit on July 4th, 2016. Am I right?
Yeah, I think you're right.
Okay,
Yeah,
it was a little shy of 5 years to get there. So remember Orville and Wilbur Wright's first flight? Let's Google that. How long was Orville and Wilbur's first flight? See what Google says.
According to Eyewitness to History, Orville's brother Wilbur piloting the record flight lasting 59 seconds over a distance of 852 feet.
All right. So 59 seconds for the first flight. Here we've got the Jupiter spacecraft taking 5 years just to reach its destination.
Wow. We've come a long way, haven't we?
Wow.
That's
Seriously.
crazy.
So it turns out that Jupiter is like 370 million miles at its closest point to Earth.
Wow. So where does that put it from the sun?
It's like 500 million miles. So it took, I think, Jupiter or the Juno spacecraft about 74,000 miles per year. That's going pretty fast. But
Wow.
so it's 500 miles from the sun. So as you can imagine, it's pretty far out there on the orbit. And so temperatures out there on Jupiter are around minus 250 degrees Fahrenheit.
So your down jacket isn't going to help you very much up there.
No. So if you're looking for a commercial flight to Jupiter, so you got a round trip right there of 10 years. 5 years to get out, 5 years to get back. So it's kind of like going to the Grand Canyon. You go out, you stand at the edge, you look over, you go, oh, cool. And then
Let's
you
go
leave.
home. But 10 years.
Right. So that's 10 years in a seat, sitting in a chair.
Wow.
So if you're 40, when you leave, you're 50 when you get back.
So I'm 40 now. I have kids.
Okay.
I come back and I'm a grandfather, more than likely.
Right?
That is crazy.
And you got a big butt from sitting in the chair.
Or a flat butt.
For 10 years. That's a long trip.
That is a long trip.
Jupiter's the largest planet of the solar system. Did you know that? I guess a lot of people did know that.
I did know that, but
it's nice to refresh. Yeah, right. Things you forget.
I'm out of high school like 20 years. Maybe.
Right. It's the largest planet in the solar system. 300 times more massive than planet Earth. It's huge. I mean,
wow.
Yeah. I mean, this thing's huge. But the thing is, it's a big ball of gas. It's one of the gas giants. I think there's four gas giants. I looked that up a while back. What were they?
I think it was Neptune.
Yeah, Jupiter, Neptune.
Saturn was the other one, wasn't it?
Yeah, so Jupiter, Saturn. I'm looking at my Google here. Uranus. And Neptune. Uranus.
You just took me back to the 6th grade. Right?
Remember as kids, we all said Uranus.
We all said Uranus.
Right? It was no big deal. And then some smart kid figured it out and he said...
I think it was Ted Koppel.
He said...
Probably some
Uranus. It's just like, oh, crap. We can't say that anymore.
Yeah.
Now it's Uranus.
Now, yeah, I think I think it was like Dan Rather or Ted Koppel changed it to Uranus.
Oh, really?
And then it stuck. I honestly think that.
Oh.
For real. I feel like I remember when it... Anyway, I'm probably totally wrong.
Right.
But I feel like that's a true story. So let's just call it true.
But we all said Uranus.
I still say Uranus. I taught my kids Uranus.
Really?
Yeah. It's Uranus.
Oh, they're going to get mocked. Okay. Anyway, Uranus and Neptune, I think they're they're gas giants, but they're ice giants. Right?
Okay,
so
yeah.
They're so freaking cold that there's just all ice out there. But these are big balls. So scientists still do not know whether Jupiter has a core, a solid core.
How crazy is that?
I know. I mean, the thing is enormous. It's basically hydrogen, helium, methane, ammonia, all swirling around 380 miles an hour.
With rocks in it, I'm assuming.
Yeah, there's debris of all kinds. You know, there's four rings on Saturn, and those things are filled with debris and other swirling gases and stuff, frozen gases and stuff. So it is a very harsh environment. You probably are not going to go out there on your commercial flight. Right. If you take one, probably just going to go to the moon. Right.
Well, I mean, if that, so Ray's, I don't know what's in your coffee, Ray, but I'm just saying. No, there's a reason that they sent an unmanned craft to Jupiter.
Sure.
Right. They're not going to be dumb enough to send a human soul up there to see what's there.
Yeah, right.
But so what is Juno doing up there?
Well, it's really just a scientific mission. They want to study the composition. Like I said, it's the swirling, howling mass of gases right now. They want to find out exactly a little more detail. You get up there, there's 9 instruments on board. They're taking a lot of measurements to find out the composition, gravity, magnetic poles, trying to find out if there is a core.
Which I'm really interested in.
There must be, because of gravity.
And we were talking I didn't think of that, but we were talking if there is no core, would it be classified as a planet?
Is it a planet? I think it is.
Do you now? Why would you think? Is it because of the floating debris in there?
Yeah, I think it is such a high concentration of debris that even though it is fairly loose composition, maybe no core, it's still
a mass.
I mean, it's there. It's observable. You could observe it from Earth. You look up, there it is.
Right.
They saw it back in Roman times, and that's why they named their god Jupiter.
Who was Juno?
Juno, it was Jupiter's wife. So basically, Juno, or Jupiter, this god, shrouded himself in clouds. So you could not see, and you could never know his true nature.
Okay.
So the story goes, the myth, right?
Right.
But Juno, his wife, was able to see through those clouds. So it's a really appropriate name for the spacecraft, because Juno is going to get up there and it's going to see through, right? Look through the clouds, the stuff that's shrouding, the stuff we cannot see from here. our telescopes and so on. It's going to see through all that. We're going to get a totally new perspective on Jupiter. So July 4th, 2016, it entered the orbit. It is in orbit right now as we speak.
So it's getting data right now as we speak.
It is collecting all sorts of magnetic gravity. As I said, so we think there's a core because there's gravity, right? And actually, that's not necessarily true. Even that large collection of debris could cause or could have gravity. But anytime there's mass, there's gravity, right?
Right.
But it turns out that on Jupiter, if you weigh 150 pounds here, you will weigh 400 up on Jupiter. So you think you're dragging after work, it's like, oh, honey, I just want to sit and watch.
Well, a fortune.
So I weigh 100 pounds. I weigh 1,000 pounds. Well, up there you really will. So I mean, So there's some serious gravity up there.
I have a question, and I don't know if you have an answer for it, but as it's collecting the data, do we get that instantly?
No.
How long does it take?
And that I am not certain of that.
But it's not instant.
No, and it takes a while for those radio signals to reach Earth.
Okay.
So, no, you don't get photographs. I don't think there's any video, but they're basically snap still photos.
Right.
But, that takes a while for that to travel. You got to calculate the speed of light.
Right. Because Juno will probably not come back to Earth.
No, it's not going to come back to Earth.
Are they going to crash it onto Jupiter?
They're going to
try to get some more information.
Yeah. So basically, the mission is going to be about 6 years. Of course, close to 7 years. Of course, it took 5 to get out there. Mm-hmm. It's going to be almost 2 years on its final portion of the mission, which basically is just staying in orbit. It's going to orbit Jupiter 37 times. So it turns out that each time around, each orbit takes about 14 Earth days.
Wow.
To get around. So that ends up being 500 and some Earth days that this thing will travel around. And basically, they will let it go as long as it can go.
Right.
And then they will put it into a descent into the atmosphere, and it will burn up somewhere.
And they'll try to get as much information as it's going
down. So cool as it's going down into the atmosphere and collecting completely new information. The pictures that are going to come back on those last hours,
right,
are going to be some of the seriously cool stuff, I think. Out there for about 18, 20 months, just orbiting, just collecting. Turns out there's 9 instruments on board. There's a bunch of electromagnetic instruments, and of course there's a camera, and they will be taking pictures, and you will start to see those show up, and they are going to be pretty cool. That's going to make the news, man.
Oh yeah. So, now I have a question for you.
Yeah.
I might be. Come on, man. No, I'm just joking. So I might derail this entire podcast. Have you ever seen the movie Interstellar with Matthew McConaughey?
It could have been one of those non-memorables that I saw. You know, I watch a lot of movies.
Okay. So Interstellar, and if you haven't seen it after this description, you should really watch it. My wife hated it, but I loved it because it involves physics that really apparently were based on actual physics calculations, even though physicists aren't happy with it. Anyway, my point is, Matthew McConaughey, they have to find a new system that's similar to Earth because Earth is dying.
Oh, okay. Right. We got to colonize.
Earth is becoming a big dust bowl. And so they're moving.
Yep.
So, but he gets caught up, and here's where I'm going with this. He goes to this planet.
Yep.
And they say, if you go into this atmosphere, time is not the same.
Oh, yeah, cool. Okay,
so because you're saying it orbits every 14 Earth days.
Right.
So this is what made me think of it. So he ends up going in, and they said, if you go in, every hour is like a year, Earth a year. in this atmosphere.
Yeah, okay.
So if you don't like go down and come out
immediately,
you're old.
Yeah,
you know.
Yeah.
So he goes down. He ends up going down and he crashes, and he's down there for like 3 or 4 hours.
Crap.
Like that. So, and my time calculations are off. But when he finally gets out, I mean, he's been gone like 10 years or something like that.
Oh,
and
man.
so he ends up getting...
His kids are older than him.
Well, by the time he makes it back to Earth, his daughter, who was like... And this is a spoiler, so if you haven't seen it, hit mute right now for like 10 seconds.
And what's the name of the movie again?
Interstellar.
Yeah, go on. Okay.
So and there's a bunch of cool like time continuum stuff where he gets caught in the time continuum. He finally gets back to Earth, and his 12-year-old daughter he left behind is like 80 something, and he's still like 30.
Oh,
so
crap.
What's your take on that? And then we'll get back to Jupiter. I just want to know.
Time is absolutely relative, and so.
Do you think that's possible?
Yes.
Oh, why?
Well, you get into the Einstein's theories of relativity,
right.
And you find out that time is different relative to where you are, to the observer.
Right.
And so you have a train going by. The time is different when the train is approaching as opposed to when it's leaving. And so, yeah, absolutely, that could happen, and that would be a very weird situation to be, to have your daughter become your grandmother,
right,
in age.
Totally. Okay, I just wanted to hear, and maybe we'll do a show on physics and time continuum and all that. That might be really cool.
Time is a very weird thing, and it's very hard for the human brain to accept this idea that time is not a stationary thing,
right?
But of course, the pop culture ideas of it are also very oversimplified. Time is a very, very complex subject,
right?
But it would be fun to get into some of that stuff because it just screws with your brain.
Oh yeah, totally. Yeah. We'll get into like time travel and stuff too.
Yeah,
so that'll be a good podcast.
Yeah, right.
Okay, so back to Jupiter. Okay.
Back to the easy stuff.
Yeah. So what happens if something hits Juno?
That could be really disastrous. There are 3 really big solar arrays on it. Those are pretty fragile.
Right.
And so what Juno has done is gotten into the orbit, going the same speed as all those frozen crystals and debris and all that sort of stuff, and is all moving at the same speed, maintaining that nice, perfect orbit, and going around and just observing from there. If things could go disastrously bad, this mission could end. You don't know when it's going to end. They predict, they hope, we're going to keep this going for about 20 months or so, 500 and some days, 37 trips around. You hope that's going to happen, but it could end any time.
You never know, right?
So one of the things they've done to help that is there's a vault, basically, that the electronics are inside of. Of course, there's electromagnetic forces. I mean, you don't know what's up there. And so this thing is wrapped in titanium. There's a box. It's a centimeter thick. I mean, it's basically the thickness of your finger. This thing is encased in titanium. Nothing's getting through that. No electromagnetic pulse is going to, clear out the electronics and kill it all. And that is, of course, the hope.
Right.
You don't know.
Right. So their main concern really are the solar panels.
Yeah, the solar panels are wings. They're basically out there trying to collect solar energy. This thing's 500 million miles away from Earth. These things have to operate at minus 234 degrees Fahrenheit. So things are very, very cold.
How much power does it use?
They're putting out about 400 watts. So imagine like 4 light bulbs. And I mean, can you imagine the electrical engineers having to, everyone has their budget. Remember the lunar lander, they had that. Everyone had their budget. And you go over your budget, you're back to the drawing board.
Right.
Every one of those engineers stays right on their budget or under.
Right.
So you imagine 4 light bulbs, what it takes to power 4 incandescent. Of course, we're all on LEDs now, but
right.
4 light bulbs worth 400 watts is all this thing gets.
Wow.
But I mean, your phone, what does it take? It's got a little lithium battery that's less than a watt. I mean, so
that's true.
You can have a lot of computing power in 400 watts.
Right. So you said there's only one camera.
Yeah, there's one camera. There's 8 other devices on there. Mostly these are all electromagnetic sensors, other atmosphere sensors, trying to find the composition. What is out there? What exactly is that? Now, of course, mostly we know from Earth here. Of course, and there was another spacecraft, another probe that went up in 2003.
I vaguely remember
Galileo.
Galileo, that's right.
Yeah. They're trying to figure out exactly what is the composition, what percentage of hydrogen, methane, ammonia, helium, gases, what other debris. Is there water? H2O. Is there oxygen? We don't know.
Wow.
We don't know if there's a core.
Is this camera going to be taking like high definition pictures, or are they more like satellite?
No, these will be high def, nice, beautiful.
These are going
pictures.
to be like Hubble telescope.
Hubble, yeah,
Hubble.
Yep, Mars pictures, the kind of stuff you saw from that.
But probably even more detailed. I'm assuming.
Yeah.
Maybe we'll get our UFO.
See, the thing is, the larger the picture, the more resolution, the longer it takes to get back to Earth.
Right.
But
that'll be worth it.
Yes,
that'll be worth it. So,
oh man,
are they taking video?
I don't know about the video. My guess is no, but what is video but just a series of stills?
Pictures, yeah.
Right? And so you could take some short video and get some relative positions of things.
But again, it takes a long time.
Right. So are we going to start seeing YouTube? Hey, probably. You start seeing photos. It is going to be a very exciting time to see those photos come back.
When are they? Do you know when they're expecting to get the photos back, or some data?
That is not. I'm not sure about that right now. Yeah, but you bring up another point. There's not just pictures coming back. There's a lot of data coming back,
right?
And all of that has to share bandwidth on their radio transmitters, and it's all got to go on a 400 watt signal. So remember the podcast we did on radio and how radio works?
Yeah.
And how 50,000 watt radio station would, cover a tri-state area.
Right.
Now you got this little 400 watt thing. They probably got, computing power of a few cell phones or something.
Right.
But the rest of that's got to be for the instrumentation. And then you shut down some instrumentation and say, okay, we're going to fire up the transmitter and send our data.
Right.
So you got more than just pictures.
It's probably hard for them not to jump the gun. Like, okay, let's get the stuff down.
Yeah, we want to see something.
Very delicate operation,
Yeah. The scientists probably want the data more than they want the pictures. We have a pretty good idea what it looks like. Telescopes can see all that now.
Right.
But the data,
it's going to be all new stuff.
The poles, there's another reason this was called Juno. Of course, we had the Greek god thing. That's all fun that, Jupiter's wife can see through the clouds and all. That's kind of fun. There's another reason for this term. It's called Jupiter. So you got the JU.
Mm-hmm.
Near polar. So you got the N.
Okay.
Orbiter. Okay. So they're trying to get near the poles and find out what are the gravitational pulls there. What's the whole gravitational story? What does it look like? What is the electromagnetic?
What made them pick Jupiter? Do you know?
Well, Jupiter was actually bypassed on its way. There was another probe that made a close sling by on its way out to Pluto. But I think it was doable. Jet Propulsion Laboratories did this. They were the ones directly involved in propelling this thing out there. And I think they said,
this is our chance.
We can do this. We got the technology. Let's go ahead and get this thing out there. Of course, they had already done Galileo in 2003. It's just the next step. So why? I'm guessing it's just because we know we can do it and we want to collect some more information, because what we have now is just a lot of speculation.
Right.
Not backed up by the actual instrumentation. That's the real important stuff.
Right.
Really.
Right.
It's not the pictures. The pictures are fun to look at.
The public wants the pictures. The scientists want to know.
They want just raw numbers.
Right.
They want ones and zeros.
Right.
I mean, they want to see what is this gravitational force like?
Right.
For real.
Right.
Not just what we think it is.
Well, that's cool.
So, yeah.
This has been a good podcast.
Yeah.
I'm glad we did this. And I'm looking forward to our time continuum.
Yeah, right.
Einstein's.
Time travel.
Yeah. That's going to be fun. That's going to be fun. But we're powered by Standard Time, much like Juno is powered by
400
watts
solar.
Yeah. But Standard Time is a great software application that you can use for your business, for timekeeping, tracking, and invoicing clients, and making organizational charts, and seeing where you're at with your finances, and tracking your mileage, and the list goes on and on.
So this is like a million miles away from time tracking software. When you start talking about all this,
but that's
space travel and all.
Yeah.
This is the kind of weird stuff that we sit around talking about while we're not writing employee timesheets.
Right, exactly. And it's awesome. So, if you're interested in checking out Standard Time, you can visit their website at stdtime.com. And if you have questions, you can email us there. Also, subscribe to our podcast if you don't mind.
Leave some comments.
Yeah, we want some comments. Maybe what you'd like to hear us talk about. Maybe if, Ray doesn't say anything wrong, but if I said,
never make a mistake.
Is it Uranus or Uranus? Tell us what you think.
No.
Keep it clean, people.
Right.
And but subscribe and comment, and we'd love to hear from you. We're on iTunes. We're on Google Play Store. We're on YouTube. And then stdtime.com, we're loaded there along with some videos. We record this podcast video, so it's a good thing. So check us out there, and next time we have a surprise for you. It's going to be a good show. So tune in, and we'll catch you guys next time. We'll see you later. Bye.